Okay, in this problem I'd like to introduce the concept of torque and use it to solve a simple problem. First, we know that forces, if I have an object and I apply some force, forces can cause accelerations. A net force always causes an acceleration. But when forces are applied to objects that rotate, sometimes those forces cause a rotational effect, and that's called torque. Torque, we often write the expression torque with the Greek letter tau. Torque is R, the radius, times F, the force, but I'm going to put a little perpendicular here. So the torque on an object has to do with how far away the force is applied, the radius, and how much force is applied. But it also has to do with an angle. Another way to write this is to say R times F times the sine of the angle between them. So, just keep in mind, when I say perpendicular, this means 90 degrees, or pi over 2 radians. And remember that the sine of 90 degrees is 1. So, as long as I'm perpendicular, perpendicular means 90 degrees, as long as these two vectors are perpendicular to each other, then this sine of the angle will be 1, and so I can simply say R times F. So, that's what I'm going to do. So torque, the torque on a wrench, in this problem we have a force of 50 newtons applied to a wrench. It's applied 8 inches from the bolt, which is 20 centimeters. Assuming the force is applied perpendicular to the wrench, and therefore perpendicular to the radius, calculate the torque on the bolt. Now, if there were any angle other than 90, I would keep this sine of phi in there and put the angle that it made. But in this case, it is perpendicular, so I can simply say the radius times the force. Well, the radius is told to us in the problem. I'm not going to use 8 inches because I want my torque in Newton meters, so I'll use 20 centimeters, but written in meters, 0.2 meters. The force is already in newtons, 50 newtons, and so that gives me a torque of 10 Newton meters. And that's the unit for torque, Newton meters. It's actually similar to the unit for work. Remember, work was force times distance as well. Force in newtons, distance in meters. We called that the unit for work joule, and it also happens to be a kilogram meter squared per second squared. In this case, torque is produced when the force and the radius are perpendicular. That's where your maximum torque happens. With work, it happened when our distance and our force were happening in the same direction. That's when our work was maximum. So a little bit different there. Well, just for fun, this is a pretty realistic situation. 50 newtons is something somebody could apply to a wrench, and an 8-inch wrench would be pretty common. But what if you had only a 2-centimeter wrench instead of a 20-centimeter wrench? How much force is needed to generate this torque when you're only applying it 2 centimeters from the bolt? Maybe this is almost like trying to tighten or loosen a bolt just with your fingers. So I can set up the equation again. Move up here a little bit. That torque is R times F, and as long as it's provided perpendicular, I can simply multiply these two. But now our torque is 10 Newton meters. To get that same torque, how much force would you need when applying it only 2 centimeters away? We can work out that the force here is 500 newtons. So notice, 50 newtons when 20 centimeters away provide 10 Newton meters of torque. 500 newtons when 2 centimeters away provide the same torque. So there's kind of a linear relationship here. That means if you take a wrench that is 10 times bigger with the same force, you will have 10 times the torque. This is why mechanics and others use long wrenches to loosen up big bolts, because you need additional torque to loosen up those big bolts. All right, the next video is going to be about rolling things, so we'll move on to that.